Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. The AWS Certified Cloud Practitioner exam, currently referred to as CLF-C02, validates foundational, high-level understanding of AWS cloud, services, and terminology. In this video, we will be exploring 10 sample questions for this exam. The goal of this exercise is to review each question before exploring and eliminating incorrect answers, resulting in the correct answer being revealed. This is an essential technique for mastering AWS exam questions. Let's get started. Which AWS service provides the ability to manage infrastructure as code? Let us identify and interpret key phrases in the question that will help with answering it. The trigger phrase here is manage infrastructure as code. This is critical as it refers to provisioning and managing cloud resources using declarative templates or scripts, not ad hoc or manual methods. Think of defining your cloud architecture using code: versionable, repeatable, and automatable. Option A, AWS Code Pipeline. While Code Pipeline is part of AWS's DevOps toolkit and manages continuous integration and continuous delivery (CI/CD) workflows, it does not itself manage infrastructure as code. Rather, it orchestrates actions, like deploying code, running tests, or triggering stack deployments, but doesn't define infrastructure in a template-based way. Incorrect, because it manages CI/CD pipelines, not infrastructure as code directly. Option B, AWS Code Deploy. Code Deploy is specifically focused on automating application deployments to EC2 instances, Lambda functions, or on-premises servers. It doesn't manage or define the infrastructure those deployments run on. You still need the environment in place before Code Deploy can work. Incorrect, because it automates application deployment, not infrastructure provisioning. Option C, AWS Direct Connect. Direct Connect provides dedicated network connectivity between your on-premises data center and AWS. This service is network-centric and has nothing to do with defining infrastructure via code. While important for hybrid architectures, it's irrelevant to infrastructure as code. Incorrect, because it connects infrastructure but doesn't define or manage it via code. Option D, AWS CloudFormation. Here's the right fit. CloudFormation is AWS's flagship infrastructure as code service. It allows you to define your entire AWS environment using YAML or JSON templates, including VPCs, EC2 instances, IAM roles, S3 buckets, and even entire serverless architectures. CloudFormation enables repeatable deployments, automation, and tight integration with version control systems. It also supports nested stacks, parameterization, drift detection, and stack policies for fine-grained control. Correct, because only AWS CloudFormation lets you define and manage your infrastructure entirely through code: declarative, versionable, and repeatable. Which option is a customer responsibility when using Amazon DynamoDB under the AWS Shared Responsibility Model? Let us identify and interpret key phrases in the question that will help with answering it. The pivotal phrase is customer responsibility when using Amazon DynamoDB under the AWS Shared Responsibility Model. This model is all about who is responsible for what. AWS manages the infrastructure and services themselves, while customers manage how they use those services, including access, data, and configuration. With managed services like DynamoDB, AWS shields you from the infrastructure, but you still need to take care of how you use the service. With that clarified, let's walk through the options. Option A, physical security of DynamoDB. This is clearly AWS's responsibility. Physical security, including data center access controls, hardware security, and surveillance, is handled entirely by AWS. Customers never touch the hardware or facilities. Incorrect, because physical security is always AWS's job, regardless of service. Option B, patching of DynamoDB. As a fully managed NoSQL service, DynamoDB is patched and updated by AWS without customer involvement. You do not have access to the underlying operating system, instances, or containers, so patching responsibilities rest entirely with AWS. Incorrect, because patching the database infrastructure is not the customer's concern. Option D, encryption of data at rest in DynamoDB. This one is tricky, but still not entirely customer managed. DynamoDB offers encryption at rest by default using AWS-owned keys, and optionally, you can manage your own encryption keys with AWS KMS, CMK. While customers can choose to use customer-managed keys, encryption mechanisms themselves are implemented and operated by AWS. Incorrect, because you configure the key policy if using CMKs, but encryption implementation is still AWS's responsibility. Option C, access to DynamoDB tables. This is a textbook customer responsibility. You control who and what can access your DynamoDB tables by configuring IAM policies, resource-based policies, and table-level permissions. Improperly securing access is a common misstep in customer-side cloud security. You also manage API keys, roles, and permissions for applications or users accessing the table. It's fully on you. Correct, because this is the essence of what the shared responsibility model means. AWS secures the service. You secure your use of it. Which of the following are pillars of the AWS well-architected framework? Choose two. Let us identify and interpret key phrases in the question that will help with answering it. The standout phrase is pillars of the AWS well-architected framework. This framework is foundational to designing cloud-native systems that are resilient, secure, efficient, and aligned with business objectives. AWS defines 5 official pillars, and understanding them, not just in name, but in purpose, is critical. The 6 pillars are operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Any answer that doesn't match one of these exactly, even if it sounds close, should raise a red flag. Option A, availability. While availability is a desirable property of an architecture, and it is discussed under the reliability pillar, it is not itself one of the 5 named pillars. This is a common trap. Don't confuse attributes with framework components. Incorrect, because it is closed conceptually, but not a pillar by name. Option C, scalability. Scalability is another concept that shows up within the performance efficiency and reliability pillars, but again, it's not named as a standalone pillar. This is AWS vocabulary precision, and on the exam, exact naming matters. Incorrect, because it is an important concept, but not a pillar by title. Option D, responsive design. This one should stand out as clearly incorrect. Responsive design is a term from the web development world, often related to mobile friendliness and UI behavior, and has no direct relevance to AWS architectural best practices. Incorrect, because it is not applicable to cloud architecture, clearly out of scope. Option B, reliability. Now we're talking. Reliability is one of the 5 core pillars. It focuses on system recovery, fault tolerance, and meeting uptime requirements. It includes strategies like distributed design, failover, and automated recovery, especially relevant for high availability workloads. Correct, because it is a directly named pillar, essential for resilient systems. Option E, operational excellence. Another pillar, operational excellence, emphasizes monitoring, automation, and iterative improvement of operational procedures. It supports agility and responsiveness to changing conditions. This pillar is key for continuous improvement, deployment best practices, and effective runbook strategies. Correct, because it is a core framework component, deeply tied to successful cloud operations. Which of the following is a fully managed MySQL-compatible database? Let us identify and interpret key phrases in the question that will help with answering it. Right away, 2 phrases deserve your full attention: fully managed and MySQL compatible. These are the 2 filters you need to apply to each option. Fully managed means AWS handles all the heavy lifting: provisioning, patching, scaling, availability, and backups. No infrastructure for you to manage. MySQL compatible means the database must speak the MySQL protocol, support MySQL clients, and behave like MySQL in terms of syntax and tooling. Option A, Amazon S3. This one should be ruled out immediately. Amazon S3 is object storage, not a database. It's great for storing files, media, backups, and logs, but there's no concept of tables, rows, or SQL queries here, let alone MySQL compatibility. Incorrect, because it's an object storage service, not structured data. S3 is fundamentally not a database. Option B, Amazon DynamoDB. DynamoDB is a fully managed NoSQL database, optimized for high performance at massive scale, but it is not SQL-based and definitely not MySQL compatible. Instead, it uses its own API and query language, quite different from relational models. Incorrect, because it is managed, but MySQL compatible? Not even close. It's NoSQL. Option C, Amazon Redshift. Redshift is a fully managed data warehouse built for complex analytics and large-scale reporting. It uses SQL, yes, but it's based on PostgreSQL, not MySQL, and it's designed for OLAP, not transactional workloads. Incorrect because of wrong compatibility. It's PostgreSQL based and designed for analytics, not MySQL style operations. Option D, Amazon Aurora. Now we're in the sweet spot. Amazon Aurora is a fully managed relational database built by AWS for high availability and performance. Crucially, it comes in two flavors: Aurora MySQL compatible and Aurora PostgreSQL compatible. Aurora MySQL is wire compatible with MySQL, supports MySQL clients, and improves upon standard MySQL with better throughput, failover, and replication, all without customer-side infrastructure work. Correct because it is fully managed and directly MySQL compatible. This checks both boxes. Which fully managed AWS service assists with the creation, testing, and management of custom Amazon EC2 images. Let us identify and interpret key phrases in the question that will help with answering it. The key phrase here is fully managed AWS service, combined with creation, testing, and management of custom Amazon EC2 images. So we're specifically looking for a service that is fully managed. AWS does the heavy lifting, no manual server management required. Focuses on EC2 image lifecycle, not just launching instances, but actually building, testing, and versioning custom Amazon machine images, AMIs. That means we're not just talking about using AMIs, but actually automating how they're created and maintained. Option B, Amazon Machine Image AMI. It might seem like a good fit because AMIs are the building blocks of EC2 instances. They are the images we launch from. But here's the catch. AMI is a resource, not a service. You can create and use AMIs, but they're not a managed service that automates or assists in building or testing them. There's no automation, no pipeline, no management tooling. Incorrect because it is as an object, not a service, so it doesn't meet the fully managed requirement. Option C, AWS Launch Wizard. This is a great tool for simplifying the deployment of complex applications like Microsoft SQL Server or SAP by orchestrating the launch of the required EC2 instances, storage, and networking. But it doesn't handle creating or managing AMIs. It's about launching stacks, not building images. Incorrect because it helps with deployment, not image lifecycle management. Option D, AWS Elastic Beanstalk. Elastic Beanstalk abstracts away infrastructure and allows you to deploy web applications using pre-configured environments. It manages the provisioning of EC2 and auto-scaling, but again, you don't build custom AMIs here. It uses standard images behind the scenes and doesn't provide a managed AMI pipeline. Incorrect because it manages app environments, not custom EC2 images. Option A, EC2 Image Builder. This is the correct and purpose-built answer. EC2 Image Builder is a fully managed AWS service that automates the creation, hardening, testing, versioning, and distribution of custom Amazon machine images. It allows you to define pipelines that include pre-installed software, security configurations, and testing steps. It integrates with CloudWatch, SNS, and IAM, enabling secure, auditable automation for your AMI workflows. Ideal for DevOps pipelines, compliance, and enterprise repeatability. Correct because NOR. This service does exactly what the question describes, and it's fully managed. A developer has been hired by a large company and needs AWS credentials, which are security best practices that should be followed. Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. The heart of this question lies in the phrase, security best practices, in the context of granting AWS credentials to a new developer. This tells us we're not looking for just what works. We're looking for what's recommended by AWS as part of a secure, well-governed cloud environment. We're dealing with two main themes: least privilege principle, giving users access only to what they need; strong credential management, including password policy enforcement and account security. Option B, share the AWS account root user credentials with the developer. This is a critical violation of AWS best practices. The root user has unrestricted access to the entire AWS account, and its use should be strictly limited, ideally disabled except for essential tasks. It should never be shared or used for day-to-day operations. Incorrect because it is completely against AWS guidelines. Sharing root credentials is a severe security risk. Option C, add the developer to the administrators group in AWS IAM. This may be tempting, especially in small teams, but it directly contradicts the principle of least privilege. You should only grant admin privileges when absolutely necessary. Developers should be given specific permissions relevant to their roles, not blanket administrator access. Incorrect because it gives too much power, violates least privilege, and invites risk. Option D. Configure a password policy that ensures the developer's password cannot be changed. This is not only not a best practice, it's actively harmful. Users should be encouraged, and sometimes required, to change passwords periodically. Disabling the ability to change a password undermines account security and prevents recovery if a password is compromised. Incorrect, because it disempowers users and weakens security. Not a recommended practice. Option A. Grant the developer access to only the AWS resources needed to perform the job. This aligns perfectly with the principle of least privilege, a foundational security concept in AWS. IAM roles, groups, and policies should be tailored to what the developer needs to do. No more, no less. Correct because precise, targeted access is a core AWS IAM best practice. Option E. Ensure the account password policy requires a minimum length. Strong password policies are a first line of defense. Enforcing a minimum password length is a basic but critical control to reduce vulnerability to brute force attacks. AWS IAM allows you to set policies that govern this, and it's a best practice to enforce complexity as well. Correct, because strong password policies are essential for protecting credentials. An online gaming company needs to choose a purchasing option to run its Amazon EC2 instances for 1 year. The web traffic is consistent, and any increases in traffic are predictable. The EC2 instances must be online and available without any disruption. Which EC2 instance purchasing option will meet these requirements most cost-effectively? Let us identify and interpret key phrases in the question that will help with answering it. Looking at the scenario, a few key details jump out. The company needs to run EC2 instances for a full year, which clearly suggests a long-term commitment model. The traffic is described as consistent, meaning the workload is predictable and steady. Even the increases are predictable, so there's no need for reactive or burst-based scaling. But the most critical detail is that the instances must be online and available without any disruption. That tells us reliability is essential. No interruptions can be tolerated. So the ideal purchasing option needs to be cost-effective over 1 year, suited for steady workloads, and must ensure continuous availability. Option A. On-demand instances. On-demand instances are flexible and require no long-term commitment. They're perfect for unpredictable workloads or short-term needs. However, they are the most expensive option for long-term, consistent use, like running EC2 for an entire year. Incorrect because it is highly reliable, but not cost-effective over a 1-year steady workload. Option C. Spot instances. Spot instances offer deep discounts up to 90% off on-demand pricing. But they come with a major catch. They can be terminated by AWS with only 2 minutes notice when capacity is needed elsewhere. This clearly violates the requirement of no disruption. Incorrect because it is most affordable, but completely fails the availability requirement. Option D. Spot fleet. A spot fleet helps manage multiple spot requests and can diversify across instance types and availability zones. But it still suffers from the same issue. It's built on spot instances, which can be interrupted. Even with allocation strategies, it doesn't guarantee zero disruption. Incorrect because it is more resilient than individual spot instances, but still not disruption-free. Option B. Reserved instances. Reserved instances, specifically standard reserved instances, are designed exactly for this use case. They allow you to commit to 1-year or 3-year terms, offering significant savings, up to 72% compared to on-demand pricing. Since the workload is consistent and predictable, reserved instances let you lock in capacity and pricing while ensuring 100% uptime with no interruptions. You can also choose zonal reservations if you need guaranteed capacity in a specific availability zone. Correct, because it is the most cost-effective option for predictable always-on workloads over a 1-year period with zero tolerance for disruption. A company wants to modernize and convert a monolithic application into microservices. The company wants to move the application to AWS. Which migration strategy should the company use? Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, the company has made a strategic decision. They want to modernize an existing monolithic application and convert it into microservices. Now, the key phrase here, modernize and convert a monolithic application into microservices, does a lot of heavy lifting. This isn't just about moving to the cloud or swapping infrastructure. It's about re-architecting. The company isn't lifting and shifting what they already have. They're breaking it apart, rethinking its structure, and aligning it with cloud-native principles. Option A, rehost. Rehost, also known as lift and shift, is a fast and simple migration strategy. It involves moving applications to the cloud without any changes. This approach is great when time is limited or when an organization wants to move out of a data center quickly. But it doesn't support modernization. It preserves the monolith as is and doesn't facilitate microservices architecture. So in this case, it falls short. Incorrect because it is too shallow for what the company intends. No modernization happens here. Option B, replatform. Replatform makes slight optimizations during the move, maybe changing the OS, swapping out a self-managed database for an AWS managed one, or adjusting configuration. It improves operations, but the core architecture stays the same. It still doesn't help with breaking the monolith into microservices. Incorrect, because it is a step forward operationally, but not architecturally, still not aligned with the goal. Option C, repurchase. Repurchase typically means abandoning the current application in favor of a commercial SaaS replacement. For example, moving from a self-hosted CRM to Salesforce. While it can be transformative, it doesn't involve re-architecting or converting the current monolithic app into microservices. It's more of a replacement strategy than a modernization one. Incorrect because it is migration. A change in product, not a refactoring of existing code. Doesn't fit the need. Option D, refactor. Refactor, on the other hand, is the most comprehensive and architecture-centric strategy. It involves rewriting or re-architecting an application to take full advantage of cloud-native capabilities, like containers, serverless functions, event-driven design, and of course, microservices. This is a heavy lift in terms of development effort and time, but it is exactly what the company wants to do. Modernize and decompose a monolith into a suite of loosely coupled, independently deployable services. Correct, because refactor is the right choice. It aligns perfectly with the modernization and microservices goals. Which of the following services can be used to block network traffic to an instance? Choose two. Let us identify and interpret key phrases in the question that will help with answering it. Let's first zero in on the key phrase, block network traffic to an instance. This isn't about monitoring, auditing, or observing traffic. It's about actively denying or allowing network access. The service or feature in question must have the ability to directly influence whether traffic reaches an EC2 instance or not. Enforcement, not just insight. We're talking about tools that sit at the network boundary or firewall layer. Option B, Amazon VPC flow logs. This is a common distraction. VPC flow logs are used for monitoring and logging IP traffic flowing to and from network interfaces. They provide great visibility and are excellent for troubleshooting or auditing, but they are read-only. They don't have the ability to allow or deny traffic. Incorrect because it is great for diagnostics, but not for enforcement. No blocking capability here. Option D, Amazon CloudWatch. CloudWatch is another key monitoring service. It's excellent for setting alarms, collecting metrics, and visualizing performance data. While you can use it to trigger actions based on traffic or resource conditions, it doesn't control network access. Incorrect because it observes and reacts, but doesn't act as a firewall, not used to block traffic. Option E, AWS CloudTrail. CloudTrail records API calls and user activity across your AWS account. It's invaluable for auditing and compliance and for tracing security-related events after the fact. But again, it doesn't participate in traffic control. It tells you who did what, but not how traffic flows. Incorrect because it is a forensic tool, not a traffic control mechanism, not relevant for blocking. Option A, security groups. Security groups are AWS's stateful virtual firewalls for EC2 instances. You can configure rules that allow inbound and outbound traffic based on protocol, port, and IP range. While security groups don't have explicit deny rules, they implicitly block all traffic that's not explicitly allowed. Correct, because they directly control network traffic and are essential for instance-level security. Option C, network ACLs, access control lists. Network ACLs are another core network security tool. Unlike security groups, they are stateless and operate at the subnet level. You can write both allow and deny rules explicitly, giving you fine-grained control over which traffic is permitted or blocked before it reaches an instance. Correct, because it is used to define both allow and deny behavior, effective for blocking traffic across subnets. According to security best practices, how should an Amazon EC2 instance be given access to an Amazon S3 bucket? Let us identify and interpret key phrases in the question that will help with answering it. The phrase that truly matters here is according to security best practices. This signals that we're not just looking for a solution that works. We're looking for one that is secure, scalable, and recommended by AWS. So whatever method we choose must avoid the risk of credential leakage, be manageable, and align with the principle of least privilege. Option A, hard code an IAM user's secret key and access key directly in the application, and upload the file. This method technically works. The application could authenticate with AWS using the IAM credentials. But this is a serious violation of AWS security best practices. Hardcoding secrets in source code is dangerous because the code might end up in version control, shared with others, or accidentally exposed. Incorrect, because it is functional, but insecure and brittle, a major security risk. Option B, store the IAM user's secret key and access key in a text file on the EC2 instance, read the keys, then upload the file. This avoids hardcoding, but it simply relocates the problem. Storing secrets in plain text on an EC2 instance introduces the risk of unauthorized access if the instance is compromised or improperly secured. It also requires manual key management and rotation, which adds operational burden and further risk. Incorrect, because it is still violates best practices, just moves the risk to disk. Option D, modify the S3 bucket policy so that any service can upload to it at any time. This option goes too far in the opposite direction. It opens the floodgates. A bucket policy that allows unrestricted access from any service at any time is reckless. It violates the principle of least privilege and significantly increases the attack surface. This isn't just poor practice, it's dangerous. Incorrect, because it is overly permissive and insecure, invites potential misuse or attacks. Option C, have the EC2 instance assume a role to obtain the privileges to upload the file. This is the gold standard. AWS recommends assigning an IAM role to the EC2 instance. That role comes with a policy defining exactly what the instance is allowed to do. In this case, uploading to S3. When the application on the instance needs credentials, the instance metadata service provides short-lived, automatically rotated credentials. Correct, because it enforces no static secrets, centralized permissions management, and aligned with AWS best practices. This is the secure and scalable way. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.